Hey you guys, this is Mr. Sal. Thanks for watching. This is a quick lesson on the mean absolute deviation, which requires us to find the mean anyways. So enjoy it. Thanks for watching. Please click on the subscribe, like, and comment below. Alright, to start this lesson off, it will be important to remember what the actual mean is. A mean is just the average, or it's got to find the sum and then divide it by however many numbers there were. Well, today we're going to be learning about the mean absolute deviation, which will require the finding of the mean, but then we've got to figure out how far everything is, how far away all the numbers are from the mean, and then we find that average. That's the mean absolute deviation. So here's a good definition. Mean absolute deviation. The mean absolute deviation is a measure of variation in a set of numerical data. It is computed by adding the distances between each data value and the mean, then dividing by the number of data values, which may sound really confusing because that's written in real nerdy terms. So to demonstrate this, we will go ahead and start collecting some data and then calculate what the actual mean absolute deviation is. So to do that, we're going to calculate the height of several of you, well 10 of you actually. So let's go ahead and get those values up and count. So I'm going to need someone to do the measuring, and then, we don't need anything perfect on these, just, really just approximations for this activity. So now that we have these measurements from 10 of ye, we're going to go ahead and figure out the mean first. So we'll find the total, the sum of these. So let's just add all these together. So the sum that I got right account, 1567. So that was the sum of all of the heights. So let's go ahead and find the mean. So we will need that sum up in count, the 1567. And then from there we're just going to divide it by the 10 numbers. And we'll round it. Okay, so we get 156.7 centimeters, which I'm just going to round to 157 centimeters as our mean. The mean absolute deviation will require that we find how far away each of these numbers is from the mean. So for example, that first value, the mean is actually 157, and I'm just going to subtract that 150, the first value, and then I get a value of 7 for the 150. Let me clean that up. All right, the next one, 151, so 157 minus 151, bam, 6. And we already did 150, so that's 7. The next value is higher than the mean, so I'm actually going to end up doing 162 minus 157. Because again, we're looking at the distances. These are away from the mean. And we don't usually talk about distance in terms of negatives. So if we wanted to, you could just put absolute values on those, which is where the absolute part of this comes in. Okay. So the next one, if we did absolute value, 163 minus 157, well, then we should get 6. Well, that should allow us to find the rest of these. The next one, 14, 48, what is that? So all these purple numbers are how far away these are from the mean, all of those values. Now we've got to figure out their sum as well. So I'm just going to go through and add all these together. 7 plus 6 plus 7, 5, 6, 14, 9, 9, 1, and 11. So after adding all these, we got 75, which is the sum. But what I want is the average of those distances. So I'm going to divide that by 10, and I get 7.5. And as it turns out, that 7.5 radian is the mean absolute deviation. So the average distance each number is from the mean is 7.5 centimeters. All right, the math allows us to determine how strange or weird or freakish certain numbers are. Sometimes they're high numbers, sometimes they're low, but they're in relation to the mean anyways. So it doesn't mean that all numbers are that way. It just depends on the list that we have. And right here we have a list of 10 numbers, so that's about all the information we can go off of, right? So let's look at what this would be like on a graph. Okay, we still need the mean, right, which we have at 157, and then the mean absolute deviation at 7.5, which will help us to determine how strange, perhaps, some of these numbers really are. Here we go. So I'm going to demonstrate this with a graph, a well-aligned number line. And then at the center of that number line, I'm going to put the mean right here, which is at 157 centimeters. Now, every mean absolute deviation away from this will just be 7.5 in either direction. So just to start off, I'm going to go 7.5 to the left, and that would put me right here at 149.5. So all I did is I took 157 and I subtracted the mean absolute deviation of 7.5, and 149.5 is what I got as a result. That's one mean absolute deviation away. But I should go in the other direction as well, another 7.5. And that should put me at 164.5. All right, and so we have this range right here from 149.5 to 164.5. If you're within one mean absolute deviation, we would consider those values to be pretty normal. At least for the list of numbers that we have, okay? Because if we found a different list, of course, these values themselves could be considered extremely abnormal. So we're going to take this to the limit and go another mean absolute deviation to the left and to the right. And that would put us 2 mean absolute deviations away from the mean in both directions. So for this one here on the left, I've got 149.5 minus 7.5 puts me at 142. And then if I go from 164.5 to the right, so I'm adding 7.5, I got 172. So those are 2 mean absolute deviations. Let's go one more, and then we'll stop right here. And of course, this would put us 3 mean absolute deviations. All right, so that's 179.5 all the way down to 134.5. Now this green range, well, let's actually talk about the red range first. In this red range, or ranges, these values would be start to be considered a little abnormal. All right, and then we got that green range from here to here, and from right here to right here. These ones would be considered abnormal. Okay. Now the thing about this is, if we put it differently, if you're in the normal range, it's good. That's pretty general. It's pretty average. It's pretty mean. But when we get a little abnormal, you could say it's kind of a little weird. Okay, starting to get into the little weird stages. And once we get into the really abnormal, or the green ranges there, the abnormal, then it's really weird. Okay, start looking really weird in terms of these values. And anything beyond that would be extremely abnormal, very weird, very strange, freakish. All right. So looking at the values that we do have up in here, let's start with 150. When we look at 150 and consider that to be normal, a little abnormal, or just straight abnormal? Yeah, it's in the normal range, right? It's in, about right there, right? What about 151? Still in that range. That's pretty normal. 150 is normal, 162, 163. But what about this 171 stuff right there? Now we're looking at it, it's pretty close to the second mean absolute deviation, the edge of that. So now we would consider that to be, it's beyond 1 mean absolute deviation, almost 2 away. So yeah, we would start to consider this a little abnormal. 148, also, yeah, a little abnormal, right? 156, That's really close to the mean, so that's pretty normal. 168 though, yeah, that would put us about up in here. So yeah, that's, well, a little abnormal, okay? So if someone were 200 centimeters tall, not that they are in this class, but how normal would we consider that? Pretty abnormal, okay? Because it's well over 3 mean absolute deviations away from the mean. So part 2 of this, we have this activity for the mat as well. But now we're looking at NBA basketball players rather than students. And we're going to compare the heights of 25 professional basketball players. We don't know their names. We just have their heights right here. So don't worry about recording your heights. We're just going to find the mean absolute deviation for the basketball players. Alright, so it may be helpful to find the mean first. Well, it should be, right? So first off, before we do that, we should find the sum of these numbers, which I'll put in this box. That will be the sum. So let's go ahead and add all these together. Alright, so this is the sum that I get, 5,048 as the sum. Well, that should help us to find the mean for this. So we're going to take that sum, 5,048, and divide it by 25 values to find the mean. And when we do that, should get, 201.9? And just for the sake of this activity, we will round this up to 202 centimeters. That should make finding the distances between the basketball player height and the mean height a little bit easier for us. So let's go ahead and start doing that. So I'm going to put these numbers in red. For example, to find this first one, I've got 202 minus 181, which would give me 21. So 181 is 21 away from 202. And these are in order for us from leastest to greatest. So 184, right? 202 minus 184. That should be 18 away. All right. So 186, 16, 12, 10, and so forth. So now that we get to 203, right, now we're above the mean. So we're just going to do 203 minus 202 now, which gives us the absolute value of 1. And then 4 is 2, 5 is 3, and so forth. Alright, so all these red numbers are how far away each of the numbers are from the mean of 202. Now what we'll do is find the sum of the red numbers. Alright, so the sum of those red numbers is 200. Again, that's how far away each of those original player heights are from the mean. So now that we want to find the mean absolute deviation, all we're going to do is take that sum of those distances, 200, and divide it by however many numbers there were, 25, and we get 8. So one mean absolute deviation would be 8 centimeters for each deviation. Alright, so let's look at a graph for this one as well, or a number line. And then we can make some determinations about how weird some of these numbers are. So if I put the mean right at the center here at 202, then I'm going to go 1 mean absolute deviation to the left, which is 8 to the left. So I'm going to take 202 minus 8, which will put me 1 mean absolute deviation. So the first mean absolute deviation, 194, but I'll go 8 to the right as well, which puts me at 1 mean absolute deviation. So in the right is the positive direction, so 202 plus 8 puts us at 210. So again, we would describe this as the normal range. So let's look at the range that's a little abnormal, which would be 2 mean absolute deviations. So the one to the left, I got 194 minus 8, puts me at 186. And then 210 plus 8 would be 218 for 2 mean absolute deviations. Well, we'll do one more for 3 mean absolute deviations. And 186 minus the 8, that should put us at 178. And then 218 plus 8 puts us at 226. So seeing this on the graph and seeing how many deviations we have, let's just start with, I guess, the maximum number here, 221. 221, how many deviations is that away? Yeah, 221 would be around this area, right? So it's in that 2 to 3 range. It's a little bit more than 2. So yeah, we would start to consider this abnormal. But what about 181? This is the smallest value that we had. 181 would be, it'd be about, what, right there? So still in the abnormal range, right? A little bit more, well, more than 2 mean absolute deviations. What about a different value like, I don't know, 194? 194 is exactly 1 mean absolute deviation right here. So we start to consider that it's normal, but a little abnormal as well. Right here. All right, so looking at your guys' mean and your mean absolute deviation, right here. And we got your heights, right? So what was our smallest value for the class? 148? These two right here? Right? So if those two, 148, let's look at 148 for these basketball players, right? We got 148 centimeters. And you'll be asked to do this not only on the homework but the test. We want to be able to figure out how many mean absolute deviations exactly, well, to the 10th. How many mean absolute deviations 148 is away from the basketball players, all right? So 148, the first thing we need to do to solve that is to figure out how far away 148 is from 202. So I'm going to take 202 and subtract my 148. So 148 centimeters is 54 centimeters away from the mean, right? And then to figure out exactly how many mean absolute deviations that is away from the mean, we'll just divide this by 8. Very good. That's how much the mean absolute deviation is for these basketball players. 54 divided by 8. So that's 6.75 mean absolute deviations from the mean. So if this person at 148 centimeters were playing basketball in the NBA, would we consider that normal? Not at all. Okay. Which is okay. All right. I mean, even if when we looked at that highest number, right, 221, that's already pretty abnormal. It's just if you were 148 centimeters playing basketball in the NBA, you would be a freak show. That's a good thing, right? That's a compliment. No, it's a good thing. It's like when the people call you a freak show, it's like, whoa, yeah, that person's really good at basketball.